Good afternoon, class. We are looking at Chapter 3 derivatives. Here's section 3.7, derivatives of the log functions. We have covered many different topics, and we are going to move on to the derivative of a log function. And what you're looking at is the synopsis of that. The derivative of ln x is 1 over x. Derivative of ln u is 1 over u. du dx and g of x is 1 over g of x, g prime of x. And if the base changes, 1 over x ln b, and the derivative of log of f of x with base b is 1 over f of x ln b times f prime of x. We're going to discuss that shortly. Number one, reminding you of all the formulas we have learned. Here's the definition. The derivative of x is 1, and if you have a constant, you can take it out. The derivative of sum is the sum of the derivatives, and the difference of difference is the difference of the derivatives. Definition of the number e is the limit of 1 plus 1 over n to the power of n as n approaches infinity, or e is a number such that the limit of e to the power of h minus 1 over h as h approaches 0 must be 1. Then we looked at some basic differentiations from the constant to the power rule to the trigonometric functions such as sine, cosine, and so forth. The product rule, the quotient rule, exponential functions and their derivatives, power rule resulting in the extended power rule, and composite function resulting in the chain rule. And now we are adding the new stuff, logs. Let me remind you of what we learned in algebra, logarithmic properties. If b is larger than 0 and it's not equal to 1, y equals log x base b is equivalent to x equals b to the power of y. Remember, log is simply an exponent. So as we look at this one, x equals b to the power of y, or y equals log x base b, they have the same base, they have the same exponent. So to have a better understanding of that, if you look at this one and the following arrow, just follow the arrow, b to the power of y is x. And if we can go from one format, logarithmic format, to exponential format, and vice versa, that means the properties will be understood easily. So in the case of a general case, as I mentioned, this means b to the power of y equals x. It gives rise to the following properties of logs. Log 1 base b is 0, log b base b is 1, log b base b of b to the power of x equals x, b to the power of log x base b equals x, log of x y equals log x plus log y, all of them base b, log of x over y equals log x minus log y base b, and log of x to the power of n is n log x, all of them base b. What are those? First and foremost, just follow this arrow, b to the power of 0 is 1, b to the power of 1 is b, and so forth. Then these two are referring to the fact that logarithmic functions and exponential functions are inverse each other, inverse functions. This is called the product rule. This is called the quotient rule. This is called the power. In the case of a common log, we don't write the base. When we don't write the base, it means the base is 10. We don't write it in this format. We write y equals log x, and we should know the base is 10. Therefore, 10 to the power of y is x. And we can make this transition, first and foremost, drop all the bases. Remember, the base is b here. You just, when you write log no base, that means the base is 10. So the last three is very straightforward, so is the first one. But what about 2, 3, and 4? Look at number 2. Log base b of b. Because this means the base must be 10, so log 10 must be 1, and 3 and 4, the same thing. Base is supposed to be 10. Natural log. When we write y equals ln x, it means e to the power of y is x, and it means the base is e. We don't write it in this format. And it gives rise to the following properties. Again, look at this one. Just use ln. The last three are obvious. The first one is obvious. And in this cases, if you look at number 2, log base b of b is 1. Then because you write ln, the base must be, then ln of e must be 1, ln of e to the power of x must be x, e to the power of ln x must be x. This is understanding the properties going from one format to the next. Because exponential functions and logarithmic functions are inverse of each other, y equals e to the power of x and y equals ln x, they are symmetric with respect to the line y equals x. Change of base formula indicates log x base b is log x over log b with any base, for example, a. But more specifically, we go to a common log or natural log for the sake of evaluation. As you look at this graph, you should recognize the following. That means if I start with the first one, this point has coordinates 1, 0. ln of x is negative when x is between 0 and 1. It's referring to this portion of the graph. ln of x is positive when x is larger than 1. It refers to this portion of the graph. So pretty straightforward. Let's remind everybody of logarithmic format versus exponential format, something that we all should be very comfortable with. So log base 3 of AD1. How did we approach that if we didn't know the answer in algebra? We said, okay, this should be x. Therefore, 3 to the power of x must be AD1. And because AD1 is 3 to the power of 4, then x must be 4. And that's exactly what happens here. This is 4 because 3 to the power of 4 is 8. What about log base 25 of 5? Again, we don't know. This is what we did in algebra. We would write 25 to the power of x is 5. And we know 25 is 5 squared. So you have 5 to the power of 2x equals 5. And 5 has no exponent, means it must be 1. 2x is 1. X is 1/2. So the answer is 1/2 because 25 to the power of 1/2 is 5. As far as the last one is concerned, the answer is -3 because 10 to the power of -3 is 0.001. And I want to remind you of powers of 10. So log 10 is 1. Log 100 must be 2. Log 10,000 must be 4. So take a look. 1 0, 2 zeros, 4 zeros. When it comes to decimals, log of 0.1 is -1. Log of 0.01 is -2. This has one decimal. This has two decimals. And this one has 1, 2, 3 decimals, so -3. So this is just to remind you how we dealt with common logs. Let me erase the work. And now we want to rewrite those accordingly. So we are going to go from logarithmic format to exponential format. So very simply, this is 5 to the power of 4 equals 625. So let me just put the arrow. Seven squared is 49. One third to the power of negative 4 is 81. 81 to the power of 1/4 is 3. 1/2 to the power of negative 5 must be 32. So those are very straightforward, everybody. Now, what about ln s equals t? Remember, when you see natural log, that means the base is e. E to the power of t must be s. When you see log, no base, the base must be 10. So 10 to the power of q must be p. So it's very straightforward. Again, the purpose of this example, this warm-up example, was to remind you of everything we've learned in algebra. Make sure you're comfortable with that so we can move on easily, okay? Now, what is the derivative of y equals ln x? We don't know. But we do know this means e to the power of y equals x. And we know how to differentiate this using implicit differentiation. E to the power of y is itself times y prime, and x is 1. To solve for y prime, we're going to divide by e to the power of y. And as you know, e to the power of y is x. So the answer is, if y equals ln x, y prime is 1 over x, which means all you have to do, write its reciprocal, flip it over. That's all you have to do. Therefore, if you have the derivative of ln x is 1 over x, x can't be 0. By the way, the reason we use absolute value because the domain is 0 to infinity, as you know. By the chain rule, if instead of x, we have g of x is 1 over g of x times g prime of x. This is by the chain rule. And if we call it u, because remember, u is the same as g of x, d dx of ln u is 1 over u du dx, where u must be positive and u can't be. Actually, when you write u is positive, it takes care of u can't be 0. All right, let's move on and look at the first example using the fact that the derivative of natural log, you flip it over. So let's flip this over. Y prime is 1 over 5x minus 1, because this is g of x times g prime of x, which is 5. And all you have to do, just rewrite it as 5 over 5x minus 1, and you're done. What about y equals ln x cubed? There are two ways to do it, and I'm going to do both ways. First, just the way we did it here, flip this over. So y equals ln x cubed, 1 over x cubed. So we got 1 over g of x, and then g prime of x. The derivative of x cubed is 3x squared. Bear in mind, when you want to differentiate, write the formulas from memory. From memory, I can't, emphasize this enough. Not from the PowerPoints, not from the notes, not from anywhere. You are doing from your memory and just plug it in. You get 3x squared over x cubed, which means 3 over x, and you're done. Now, this is simple enough that this will do the job. However, the more complicated the log, the easier the second way. And that means ln of x cubed, according to the power rule, becomes 3 ln x. And now we are going to differentiate it. So decompose the log completely and then differentiate it. So you have 3 times y prime is 3 times. Now ln x gives you 1 over x. And again, you have to assume x is in the proper domain from 0 to infinity. So 3 times 1 over x, or 3 over x. F of x is ln of 2x over 2x plus. If you just want to do it the way this one is given, ln of g of x is 1 over g of x times g prime of x, you have to flip this over. And then you have to use the quotient rule. You don't want to do that. Why not? Because it's a lot more complicated that way. So what is the easiest way? Use the properties of logs to decompose this completely. So first, I'm going to write as ln of the numerator 2x minus ln of the denominator 2x plus 1, which means I'm using property number 6, the quotient rule. Then for ln of 2x, I'm going to use number 5, and I'm going to cut it into two pieces, ln2 plus ln x. This is completely decomposed, so we can differentiate it easily. F prime of x equals ln2 is a number, 0. ln x, 1 over x. Again, ln2 is a number, everybody. Minus, following this, ln of g of x, 1 over g of x, that means minus 1 over 2x plus 1, times g prime, the derivative of the parentheses is 2, and this is the extent of the calculus. This is done as far as calculus is concerned. So I'm going to put the asterisk next to it. Done with calculus. Now we are going to continue with more algebraic steps. This is 1 over x. This is minus 2 over 2x plus 1. We need to take a common denominator to combine them. The common denominator is x times 2x plus 1. So to combine these two, 1 times 2x plus 1 minus 2 times x. We get 2x plus 1 minus 2x. These two cancel each other. And that's the final answer. 1 over x times 2x plus 1. Again, a quick recap, everybody. You can differentiate it by writing the reciprocal and then multiply it by its derivative using the quotient rule. Don't do that. Take the easy way out. Decompose it first. And it's very easy to differentiate each piece. So ln2 is a number 0, ln x is 1 over x, ln of 2x plus 1, this negative sign remains 1 over 2x plus 1 times 2, and you can finish the job easy. Five x times ln x squared. First, we're going to change this to 2 ln x by the power. So power rule number 7. And 2 and 5, we put them together, we get 10x times ln x. You can put the 10 out and just this 10 will carry, or just continue with that, which means number 10 again is easy enough. You can just deal with it the way it is. Fg requires the product rule. So we get f prime, which is 10 times g, which is ln x, plus g prime, which is 1 over x, times f, which is 10x. And we are done with calculus. These two, they give us 10. You factor the 10 out, you get 10 times ln x plus 1. Now, again, notice this 10 carries. So you could have, let me just erase the word and show you what I mean by that. You could have put this in brackets and keep it in this format. Whatever is easier for you, make sure. Y equals ln x over x, f over g. We're going to use the quotient rule. F prime ln x gives you 1 over x times g, which is x, minus g prime 1 times f, so 1 times ln x, over g squared x squared. That's it. This is the calculus part. Now, of course, there's really not much you have to do. The product of these two is just 1 minus ln x over x squared, and you're done. All right, class. So the best course of action is to decompose this using logarithmic properties. This is ln of 3 plus ln of x plus ln of x plus 4 to the power of 5. 5 becomes the coefficient. So ln of 3 plus ln of x, and this is ln of x plus 4 to the power of 5. 5 becomes the coefficient because that's the power. Now, ln 3, we are going to differentiate. ln 3 is a number. The answer is 0. Plus ln x, 1 over x. Now we are going to differentiate the last part. First, we see number 5, we keep it. Then ln of x plus 4, we follow ln of g of x, and we flip this over, 1 over x plus 4. We need g prime. The derivative of the parenthesis is just 1, but write it just to be on the safe side. And this is the extent of calculus. In other words, right here, we are done with calculus. So that was an algebraic step using algebra and properties of logs. Now we are adding 1 over x and 5 over x plus 4, which means we need to add them up, taking a common denominator. Common denominator for these two fractions is x times x plus 4. 1 times x plus 4 plus 5 times x. This gives us x plus 4 plus 5x. These two add up to 6x. So the final answer, y prime is 6x plus 4 over x times x plus 4.